Next, we're going to be reusing some of the stuff we were using before, namely the color adjustments. So we have these two that we can reuse so that our bursts actually inherit the same type of color that we had before. Not even going to change anything on these. And also the same thing for the velocity. We're going to reuse the velocity, and we're going to be applying this velocity to those particles as well. Same thing, using a target. We can play with the parameters a bit. I think the main thing would be probably to just offset these noises so they don't match exactly the other ones, but other than that, we should be okay. After that, we just go on directly to top network, which is going to be where we're going to be simulating our blast B. Let's call it blast B. I'm gonna put this more towards the middle, and I think we can kind of put this more towards the side. Let's create some indications of what's actually happening here. So I'm going to create a node. I'll type blast A. Change the size to large and hide background. This is still too big. Put it here, create a copy, Alt, click and drag. Blast B. And I'm going to call this the target. Okay, so we have a basic structure. Inside the DOP network, what we're going to be using is a flip simulation. So we'll need a flip object. We'll need a flip solver. And we'll need a volume source. Bring in the particles. Pretty much it. On the volume source, we're going to be using the first context geometry. Okay. The flip object, we're going to be controlling the density and the final resolution of our simulation based on this. So let's go with 0.01 and let's connect this value. Copy parameter, and let's connect that value to the emitter, the flip source. So here, base relative reference. That way we just change it here. Finally, let's bring in our static object. We can actually grab it directly from the other simulation. So if we go inside here and we grab these two, Control C, Control V, and we just connect these. The next thing we need to do is establish the size of the simulation area. And to do that, what I'm going to do is actually I'm going to go here to the blast, pick one frame that I feel like is a good reference for the overall size of what we need. Frame 1074 could work. So I'm just going to grab that frame, type file, and here on the file lab sketch, I'm going to go to the advanced and just grab Control A, Control C, and here Control V. So now we're just loading that particular frame. Okay, no animation there, just that particular frame. And with that particular frame, we're going to create a bound. And that might be, it's already after the point where it stops emitting. So maybe let's grab another frame. Let's go with 70. Yeah, we still have that position. Create some bounds. Still need to kind of expand a bit on the x-axis, so maybe 0.2. Everything else should be okay. We can expand it a bit towards the side or towards the top if we feel the need to. Let's actually do that. 0.2 everywhere. Maybe not towards the back. 0.2, 0.2. This gives us enough room. Create a null, and this null is going to be called out flip bounds, and it's going to be really useful for us. Inside, we go to the flip object first just to remove this initial data. Don't need anything in there. Then we're going to be using on the flip solver, the volume motion. This is where we're going to be applying the size of that box. So we have it here for quick reference. And I'm just going to add a spare input, which is going to go to the bottom. So if you don't see it, just make sure you slide this all the way to the bottom and just paste this there. And on the volume motion, we're going to be referencing that with the B box -1, and then d underscore x size. Now we copy this, Control A, Control C, hit Tab, Control V, and just switch the X for Y. Tab, Control V, switch the X for Z, and we have the size. Now we need the centroid. Same thing, so I'm going to be using the centroid. -1, d underscore X, Control A, Control C, Tab, Control V, switch to Y, Tab, Control V, switch to Z. And now we have exactly that little box that we made before. What else? A few adjustments we want to make here on the flip object. So there are a few things we want to adjust on our flip simulation. The volume source, we need to make sure we're sourcing flip. So it's grabbing everything it needs to grab. Then on the flip solver, sub steps, I'm going to leave it. Particle motion, let's make sure we H our particles, we add some ID to our particles, and we also reap the particles. We don't need any reseeding to happen. Everything else I'm going to leave as is. Volume motion sounds fine. Do not collide with the volume limits. Let's kill them. And yeah, I think that's it. And we should be ready to go. Let's have a look at how this is going to be behaving, and let's see if we have some flip simulation going. We do. Looks really bad, and that's easy to fix. Go to flip object. On the guides, we have our particles that are being displayed as sprites. Let's have them look as particles. And once again, hit play. There we have it. So we have one water balloon hitting, another water balloon hitting. And this is pretty much the type of shape of the splash that I was looking for. Okay. Kind of radiates all over. If you can look from the back, all directions. Really nice bursts of energy that we can associate to our blast. Definitely. Okay, so we're on the right track. We have everything pretty much set up. We just need to work on this to have it behave properly. Okay, so let's do that on the next lesson.